Okay, so now off we go to question number 3, the one that I've been looking forward to actually working on, at least to a certain extent. I made myself wait and do them in order. But here we go to the question that you guys have been looking forward to hearing about. Okay, so we've got this company, and they have spinning toys according to this equation right here, where they can go ahead, you can imagine making this into a spinning toy, a top or something like that, where C is some positive constant. So yeah, that kind of bugged some of you guys because they threw a constant in front. But you'll notice in the very, very first problem, they went ahead and told us what that constant was. And so if we're going to find the area under this thing right here, we're just going to go ahead and integrate that again. But they told me that C was the number 6 for that problem. So we have 6. Remember, we can pull that constant in front, x square roots of 4 minus x squared dx. Now, secondarily, there's a little piece that is actually under the surface that you have to look at this and realize that if this ends up intersecting at the origin right here and somewhere over here, you could look and tell that if x is 0, in fact, that would make 0 happen. And the other value where that would happen would be either 2 or -2. But based on the way that the graph is made, they're implying that it has to be the positive values only. So we're going to be integrating from 0 to 2 of this thing, and that's part A. So here we go. So if we're going to integrate that, clearly we need to do a little u substitution. So u is going to be 4 minus x squared, or in other words, du is -2x dx. Now, of course, why did I write it that way when I said something else? Let me fix that. Let's fix that. -2x dx. Now, of course, when you look over here at this thing right here, you realize that we do not have that. So I'm going to bring that -1/2 over. So now that I have that x dx sitting. So we're going to do a little change. And I now know that x dx is -1/2 of a du. And right in here, let's see, the u is right here. That is u to the 1/2. So this has become a much nicer integral, but we have one more little piece to do, because remember, if x is 0, that would make u 4. And if x is 2, that would make u 0. So that's actually kind of a nice thing, because when I first looked at this problem, I went, whoa, hold up, we got this negative here, but that actually works out quite well. So we actually have 3 times the integral from 0 to 4. Of u to the 1/2 du. So now we're kind of set and ready to go. Now that allows me to do a u to the 3/2 with a little 2/3 in front, and we're going to evaluate that from u equals 0 to u equals 4. Now again, this is not a calculator active session, but this is kind of nice because we're losing 0. That's not going to happen. So we just have to figure out what 2u to the 3/2 is if we allow u to be 4. So 2 times 4 to the 3/2, well, 4 to the 1/2 is 2. 2 cubed is 8, and 8 times 2 is 16. Check, we have found the area, provided that the C value is in fact 6. We're done with that first part. Now, for the second part, part B, it says, it is known that the derivative of this is right here. For a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2. Boy, that was a lot. What is C? Well, again, if this is the derivative and you want to find the maximum value, well, the maximum value happens where the derivative is 0. So what we need to do, I'm going to go ahead and write this on lined paper here instead of putting it on the other. But we're going to just go ahead and take that derivative, and we're going to set it equal to, we're going to take the derivative with all of this stuff right here, and we're going to set it equal to 0. Now, obviously, we know that if a fraction is set equal to 0, then that means the numerator must be equal to 0. And so the derivative, I think I wrote that down kind of funny. I actually wrote something in my notes a little bit weird. Let me go back to that. So dy dx, recall, is C times, I'm just looking at the problem that is there, 4 minus 2x squared all over root 4 minus x squared. So of course, if I want to find out where this derivative is equal to 0, because that's where that would happen, let's go ahead and do that. Now, clearly, if the fraction is 0, then it has to be the numerator portion. We could divide that 0, the c across. Since it's a positive constant, it's not going to affect our answer, dividing both sides by c. A little bit of movement over, keep moving things around, and I'm going to get plus or minus root 2. But of course, in this particular implication, we are just going to use root 2. So we now have our magic value. But we know that the actual function for this thing, y, was equal to cx square roots of 4 minus x squared. And we actually found that the value that that happens at is when x equals root 2, and that that actual value of y at that maximum was 1.2 inches. So I know that y is 1.2, and I know x is root 2. So if I just replace all the x's with root 2's, now this is a little interesting because root 2 squared is 2. 4 minus 2 is 2. Well, they actually made something quite nice here because this is obviously the number just plain old 2. And so c, in order to attain that maximum value, has to be 0.6 inches. And that kind of polishes up part B. And then off we go to part C. So what we're going to do is we're going to take this cross section like this, and we're going to revolve it. So remember, when you revolve it, you've got this thing right here, and we're going to make this kind of a disc like this. And keep in mind that the radius of revolution is y. So I know the volume of which is going to be some kind of a pi y squared dx. Again, from 0 to about 2, because that's just kind of how the mathematics works. So we have pi, and then we're going to go ahead and take r, which was the major function that we had. I still have it written right here. So we're going to take cx root 4 minus x squared squared dx from 0 to 2. And it says that the volume in that given story was supposed to be precisely 2 pi. See, in our story right here, it says, for another spinning toy, they told me the answer for the volume being 2 pi. So what would that C be? So that's a little bit interesting. Well, obviously, you can see right now that if I wanted to, at the very, very early onset of this equation, I could kill the 2 pi's and just ignore that portion. Next, I could actually go ahead and square this thing out, and I'm going to have a c squared, I'm going to have an x squared, and I'm going to have a 4 minus x squared dx, because the square is going to fix the square root. This is all one chunk, and it's still equal to 2. Again, we have talked a lot about making sure that you get things into our good old friend, the power rule, if ever you can. And by doing that, it's led me to a nice little situation where I can integrate this. This is 4/3 x cubed minus 1/5 x to the 5th. Make sure that I wrote that down correctly. That's 4/3 x to the 3rd minus 1/5 x to the 5th from 0 to 2 is somehow supposed to be the number 2. Sorry, I did not move that up. Now, this looks like it might be a bit of a challenge to get all the way there, but of course, plugging in 0 is going to be trivial. 2 to the 3rd is 8 times 4 is 32. 2 to the 5th is 32. Pretty sure they actually did that much, very much on purpose, because you're going to notice that I could factor the 32 out of the 2 tops. Now, again, if you did not do that, it's not really that big of a deal. So I noticed that if I played that game, this is in 15ths. This is 5/15 minus 3/15, which is exactly 2/15. And so I'm to here. There's a variety of ways that you could execute this from this next step, but I kind of noticed that in a sense, I could cancel out these 2 2's right here. Oh yeah, I forgot that was actually c squared. Let's fix that. So by doing a little bit of movement of this thing around, I ended up with a c squared is actually 15 over 32, making c the square root of 15 over 32. And you do know that this is supposed to be a plus or minus, but in the given data in the problem, it even says quite specifically that c is a non-zero positive constant. And so we are good to go. And that is the spinning toy problem from start to finish, because they didn't ask me to explain anything. They just said, what is that solution? And I am done with number 3. So I'll see you back for number 4.